Welcome to this explainer. Today, we're diving deep into the fantastic Ghauri Education curriculum to learn Python from absolute zero. Whether you've dabbled in tech before or you're starting with a completely blank slate, you're in the exact right place. We're going to break down the fundamentals step by step, guiding us straight to the core of what makes programming so incredibly empowering. Let me ask you something. Have you ever actually wanted to code? If you've ever wanted to learn how to talk to computers, to give them instructions using a language that honestly reads almost like plain English, well, this is your perfect starting point. You don't need a background in advanced mathematics or computer science. Honestly, you just need curiosity. All right, Section 1, the power of Python. Let's get right into it. Before we even think about writing a single line of code, you need to know why Python is basically the undisputed heavyweight champion of the programming world right now. Its real-world impact is absolutely massive. It's the primary language of choice for some of the biggest, most innovative organizations on the planet. I mean, when you watch a movie on Netflix, scroll through Instagram, search on Google, or literally when NASA calculates orbital mechanics, Python is working behind the scenes. So learning this language means you're learning the exact same tools used by top-tier engineers. But it goes way beyond just the big tech giants. Python is incredibly versatile. It acts as the foundational key to unlocking the most exciting and rapidly growing fields in tech today. Whether you want to build the next big artificial intelligence model, analyze massive datasets, automate your boring daily tasks, or secure networks and cybersecurity, Python is your key to the door. Now, here's a totally wild fun fact about its history. Python isn't some new fad. It was actually created by a Dutch programmer named Guido van Rossum way back in 1991. And get this, the language was actually named after the British comedy show Monty Python's Flying Circus, not the snake. Guido just wanted a name that was short, unique, and a little bit mysterious, and, well, it definitely stuck. Moving right along to Section 2, your first line of code. Okay, it's time to actually get you set up so you can experience that immediate gratification of writing your very first program. The process is remarkably simple, and we've broken it down into 3 easy steps. First, just head over to python.org and download the version for your operating system. Second, and hey, this is a crucial point right here on step 2, when the installer opens, make absolutely sure you check the little box at the bottom that says Add Python to Path. If you miss that, your computer won't know where to find Python later. Finally, install the professional, free code editor like Visual Studio Code or VS Code, which is exactly what developers worldwide use to write their scripts. Once you're all set up, you simply save a new file with a .py extension and type this exact phrase, print hello world. This is a total rite of passage for all programmers. In Python, print is what we call a built-in function. It literally tells the computer to take whatever text is inside those brackets and quotation marks and display it right on your screen. It's clean, it's readable, and it works instantly. Next up is Section 3, variables and data types. Now that we're communicating with the machine, let's explore our digital storage system. Think of a variable simply as a labeled box where you put data. You get to name the box whatever you want, and you can put almost anything inside it. You could create a box labeled name and put the text Ahmed in it, or a box labeled age and put the number 20 in it. Once they're stored, you can use these variable names to perform actions, like having the computer print out a greeting, or even performing basic math by adding or subtracting your number variables together. But here's the thing, the computer needs to know what kind of data is in that box, and that's where data types come in. Every piece of data has a specific type. You've got strings, which are just text wrapped in quotes, integers, which are solid whole numbers, floats, which are numbers with decimals, kind of like a price tag, and finally, booleans, which act like a simple light switch. They're strictly true or false. And hey, if you ever forget what's inside your box, you can always check a variable's type using Python's built-in type function. Now, this brings us to a super common beginner trap, so listen up. Often, you're going to want a user to type information into your program, right? You do that using the input function. But the absolutely crucial point here is this. Input always hands that data back to you as a string. Always. Even if the user types the number 5, Python sees it as the word 5. So if you want to actually do math with that user input, you have to run it through the integer function first, converting it from text into a usable mathematical integer. Let's dive into Section 4, logic, conditions, and loops. This is where we get into the actual brain of the program. How does a computer make decisions? Well, surprisingly, a lot like we do in real life. If it's raining, take an umbrella. Else, don't. Python uses if,
elif, which is short for else if, and else statements to check conditions. If the first condition is true, it runs that specific block of code. If it's false, it just drops down to the next one. And what's absolutely vital to notice here is that Python relies heavily on exact space indentation. Those spaces before the code, they aren't just for looks. They are exactly how Python knows which lines of code belong to which specific if or else block.
Next up, we have loops. Look, programmers absolutely hate writing the same code over and over again. To avoid that, you use loops. You'll use a for loop when you know exactly how many times you want a task to repeat, like, say, using the range function to print numbers 1 through 10. On the other hand, you use a while loop when you just want the code to keep repeating infinitely until a specific condition finally becomes false. Which brings us to Section 5, lists and functions. As your programs start getting bigger, you're naturally going to need ways to efficiently organize all this data and make your code reusable. A list is exactly what it sounds like. It's a single variable that collects multiple items inside it. Imagine a single box that holds an entire grocery list of fruits. But here is the most important rule you need to remember. Lists in Python are zero-indexed. That means the computer starts counting at 0, not 1. So the first item is at index 0, the second is at index 1, and so on. And Python gives you some really simple tools to modify these lists, easily allowing you to append new items, remove old ones, or just count the total length of the list. And then there are functions. Guys, functions are an absolute game changer. Think of them like reusable recipes that you define once using the word def. Instead of writing out a complex calculation 10 different times in your script, you just write it once inside a function. You can pass custom inputs into them, those are called parameters, have the function process that specific data, and then return a final calculated value back to you. They literally make your code so incredibly clean, organized, and modular.
All right, the grand finale. Section 6, building a simple calculator.
We're going to take absolutely everything you just learned and synthesize it into one cohesive practical project. First, we'll use def to create 4 separate math functions for adding, subtracting, multiplying, and dividing. And we'll make sure our division function uses an if statement to check that we aren't illegally dividing by 0. Second, we'll use the input function wrapped in an integer or float conversion to collect the user's numbers. Third, we use our conditional if and elif logic to look at what the user actually wants to do and call the correct function. And finally, we just use print to display the result on the screen. 4 simple steps utilizing everything we've learned to build a fully working application. Just look at how far we've come. You've successfully journeyed from absolute zero, like not even having Python installed, to fully understanding the logic, variables, loops, and functions required to power a real application. You seriously now have a superpower, the ability to speak directly to machines. The foundation is laid and the tools are right there in your hands. So the only question left to ask is, what world-changing idea are you going to build next?